Hello everyone, I'm Mohit Srivastava, a lead developer advocate at Salesforce. And today I'm going to talk about how you can automate your complex business processes using low-code tools like Salesforce Flows and the on-demand programming language of Salesforce, Apex. Now, before we deep dive, let me give you information about our social channels and how you can connect with us. The first one is a link to our developer website. From there, you can navigate to our blogs, find information on upcoming webinars, and much more content. The second link is the link to our Twitter handle, where you can connect with us. We are listening via our social channels. You can find us on Twitter, LinkedIn, and YouTube. Make sure you hit like and subscribe to our YouTube channel by clicking the bell icon to receive notifications. This is our safe harbor statement. Salesforce is a publicly traded company, so please make purchasing decisions based on current offerings that are generally available. At Salesforce, we want to empower everyone to automate complex processes. We have low-code tools like Salesforce Flows and App Builder for administrators and business users. We've got several tools for pro-code development in Salesforce, as Lightning Web Component and Apex on Salesforce Core, and the ability to use any open source language in Heroku. As today we are focusing on writing business logic automation on Salesforce Core, we'll mainly talk about Apex. Salesforce Flow is a low-code tool that business users and administrators with limited knowledge of code can use to write automation using clicks. As a Salesforce developer, one should know how to use Salesforce Flows to write automation. With Flows, you can write business automation quicker. Salesforce Flow can interface with Apex and Lightning Web Components. For example, as a developer, you can build invocable actions using Apex class that can interface with the flow, and administrators can reuse these invocable actions via drag and drop in various flows. Finally, if you're an ISV building apps for Salesforce App Exchange, you can also package and distribute your flow components. Let's take an example of how to write a record-triggered flow. A record-triggered automation is a business process that will execute when a record is created or updated. We are using ECars, a sample gallery app, for this demo. I've already installed the app in Salesforce Scratch.org using the instructions on the GitHub README for the project. The app comes with various custom objects such as vehicles and vehicle orders. We are on the vehicles tab page from where users can view the vehicles inventory and their status. While creating or editing vehicle records in Salesforce, business users would like to automatically populate the range picklist field value based on the price field. The logic for the range field assignment is if price is less than 10,000 USD dollars, then populate the range field as short range. If the price value is greater than 10,000 USD and less than $25,000, populate range as medium range. If the price is greater than 25,000, then we populate the range field value as long range. Let's see how we can use flows to accomplish this. We will make use of record-triggered flow. From the setup, we can find the flow home page. Click on New Flow button. Since we want to perform the action on record save, we select record-triggered flow. Select free form to start drafting flow. Since we want the trigger to fire before the record is inserted and updated, set the trigger to a record is created or updated. Select the run flow before the record is inserted. We want the automation on vehicle, hence choose the object as vehicle. We'll also need a condition to make sure that the flow runs every time a price change happens. Let's run this every time the price value is not null. Let's design a decision element that checks price ranges and defines routes. Think of this as an equivalent to an if statement in code. Let's name the condition as check price range. Let's define an outcome for the short price range. This outcome is executed only if the price range is less than or equal to 10,000 USD. So you pick the price there and then say less than or equal to 10,000. Let's define an outcome for the medium price range. This outcome is executed only if the price range is greater than 15,000 USD and less than 25,000 USD. So we select record.price greater than 10,000, and then we add one more condition there which says record.price less than or equal to 25,000. Let's define an outcome for the long price range. This outcome is executed only if the price range is greater than 25,000. So you select record.price greater than 25,000. At this point, we are done with this decision element. Now let's connect the start element to the decision element. Our next step is to add an assignment element so we can assign the right picklist values for the range field. Think of this as a simple variable assignment statement in the code. So let's create an assignment element for populating range field for short range condition. Let's label it as populate short range. Let's go to variable section and pick the $record.range. And its value is equal to short range. Let's connect the decision element with the assignment element, and let's choose this for short outcome. Let's add another assignment statement for medium range. Let's label it as populate medium range. Again, let's choose the value, and the variable will be $record.range, which is equal to medium range. Let's connect the decision outcome of medium to this populate medium range assignment. Let's bring in another assignment, this time finally for the long range. Let's label it as populate long range. Let's say record.range equals long range. Let's connect the decision outcome of long range to populate long range assignment. At this point, we can save our flow with the name populate vehicle range. Notice that you can pick the API version and also the type. Let's save this flow. Let's prettify this with auto layout. This feature aligns your flow items automatically, making it easier to find them and add new ones. Finally, let's activate it and test the flow. I'm on the vehicles page. We see the list of vehicles. Let's click one and navigate to the vehicle detail page. Let's change the price value from 25,000 to, let's say, 50,000 USD. Let's save. As you can see, the range value changed from short to long. Now when I change it to 2000, it correctly changed to short range. Let's try changing again to 11,000. Okay, this time it's medium range. So our flow works fine. The configuration we did for Flow are metadata that can be easily versioned. Let's check the change metadata by running sfdx for source status command. And we can see that there was a Flow metadata added. Now we can pull the change metadata to our local project workspace using sfdx for source pull command. There you go. We can see the changed metadata that was added to our project. This slide shows two powerful ways to extend flows using code. You can use LWC and Aura components in your flow by adding a flow interface to the components. Flow actions provide access to all of your APIs from directly inside the flow execution. In the next section, we will take a look into how to automate your app with Pro code, specifically using triggers. Before we look into an example of how to use triggers to automate a business process, let's understand what is Apex. Apex is Salesforce native programming language. It's object-oriented, so you can use classes, interfaces, and inheritance. Apex is also syntactically very similar to Java. It is strongly typed and case insensitive. It compiles to Java bytecode. Finally, Apex provides SOCL for executing queries and DML statements for database operations. Salesforce core apps run in a multi-tenant environment, and we control more what you can do with the language so that you don't hoard our resources. Let's explore what you as a Salesforce developer can do with Apex language on Salesforce core. With Apex, you can write server-side business logic. You can then expose these methods to Lightning Web Components, Aura Components, or Visualforce. The code snippet on the left image shows how to invoke an Apex method on the right from Lightning Web Component. With Apex, you can also queue asynchronous jobs. You can queue and monitor asynchronous jobs in Apex using queuable interface. To queue an Apex class, the class needs to implement a queuable Apex interface. Apex class that implements batchable interface can process millions of records in small batches. Using batch Apex, you can process records asynchronously in batches to stay within platform limits. If you have a lot of records to process, for example, for data cleansing or archiving natively on platform, batch Apex is your friend. You can also schedule jobs using Apex. The Apex scheduler lets you delay execution so that you can run an Apex class at specified time. This is ideal for daily or weekly maintenance tasks using batch Apex. To take advantage of the scheduler, write an Apex class that implements the schedulable interface and then schedule it for execution on specific schedule. With Apex, you can also create web services, so you can expose your Apex class as REST and SOAP services. The code snippet on the left shows how to expose an Apex class as a REST services. The code snippet on the right shows how to expose an Apex class as a SOAP web service. Using Apex, you can also make third-party callouts. The callout sends an HTTP request from Apex and then receives the response. This is a small code snippet to show how you can make a HTTP callout to an endpoint using the HTTP request and response classes. There are many more use cases for Apex, like for email services, or if you're customizing approval processes in Salesforce, or working with Salesforce identity. Next, we're going to focus on how to use Apex in Apex triggers. Now let's look into what's a trigger. A trigger is a piece of Apex code that's automatically executed before or after database operations. Apex provides transactional control over the business logic execution, unlike flows where the order of execution cannot be fully controlled. Apex trigger can be fired before a record gets inserted or updated, and even further, they can be called when a record is deleted or undeleted. We use before trigger usually to validate or modify values before they are saved to the database. Use after trigger to act on confirmed data and access new record values, such as the ID or the last updated date of the record. Now, before we start looking into a demo of how to write an Apex trigger, let's understand some basic principles. So one of the best practices of writing triggers is you should always bulkify your Apex code. Make sure that your triggers work on list of records, not just single records. You can bulkify your Apex code by making sure that you do not have any SOCL statements inside for loop or DML statements inside for loops. Instead, you use collection like list or maps. Because Apex runs in a multi-tenant environment, we have limits in place. Hence, code bulkification is needed so that operations are optimal and do not hit the governor limits. As an Apex developer, you have to be conscious of what you are writing and find the best way to do things, which is a fun challenge. Triggers have context variables. Context variables provide access to old and new values. As a list with trigger.old and trigger.new, or as a map with trigger.oldMap and trigger.newMap. We will see all of these practices in action in the upcoming demo. Let's see a demo of an Apex trigger in action. We'll see how to write an Apex trigger. I'm in the ECars app. We have a trigger in the app on vehicle object to automate the task record creation when the vehicle record status field is changed to sold. Note that this is a use case for after update trigger. Here is a flowchart that shows the logic for the Apex trigger. So when the vehicle record status changes from available to sold, we need to create a task in Salesforce. Let's see this trigger in action first, and then we can deep dive into the code. I'm on a vehicle's record, and I'm gonna change the status to sold. Notice that the task record was created in the background when the record status changed to sold. Now let's see how this trigger is built. I'm in my VS Code, and you can go to triggers folder to find the trigger. The trigger name is vehicle trigger, which is also the file name. The trigger is on the vehicle object. After update here is the trigger event. You can have other events like before insert, before update, before delete, and after undelete. The trigger instantiates an Apex class vehicle trigger handler that invokes run method. Let's take a peek into the vehicle trigger handler class. This class extends from parent class trigger handler. Let's peek into the trigger handler class before we deep dive into implementation of the vehicle trigger handler. This class is a part of an opinionated trigger handler framework. You can find this class in Apex Recipe Sample Gallery app. Navigate to Force app, Classes, Shared Code, and look for triggerhandler.class. Spend some time looking into its various methods. Notice that the class has various virtual methods with just the signature. You can override these methods with actual implementation. Let's deep dive into the vehicle trigger handler class to understand how this pattern can be implemented. Note that in the constructor method, we assign the trigger context variables to various private variables. For example, trigger.old returns a list of vehicle records from the database before it was modified by the user. Trigger.new returns list of records with modifications by the user before the records are committed to the database. We want task records created after the vehicle records are marked as sold. Hence, we override the after update method of the trigger handler. We need a list of types, tasks to collect, tasks to insert. We loop over all the records of trigger.new and find if there was a change in the new and old values of the record for the status field. Notice that we have the context variable trigger.oldMap, that is a map of ID and old vehicle record. If the status is stored, we create a new task record by instantiating the task record. We populate the necessary field. Notice what ID relates task records to the current parent record. In this case, the parent record is the vehicle ID. We populate the subject. We need a DML on all the task record. Notice we collect them in a list and perform insert operation on the list. We have a DML inside a try and catch. So in case of an error, we can handle them using catch block and display a user-friendly message using add error method. Now, it's always best practice to use a trigger pattern and limit one trigger per object so that you can easily control the transaction of your logic. Also, notice that we have the DML on the list and not inside the for loop. So the best practice is always make sure that you do not have a query or a DML inside the for loop. Apex Recipes Sample Gallery app provides many more utilities and sample code for learning Apex along with best practices. So do check it out on the Trailhead Apps GitHub handle and find the project with the name Apex Recipes. Next up, let's watch a demo on how to create an Apex action that can be used in a flow as a flow element. Apex classes can be made available as Apex actions if one of their methods is annotated with @invocable method. In the ECars application, we want to provide a flow element that administrators can use to send web push notification to a third-party service hosted on Heroku. The web push service class has a method flow invoked web push that is annotated with @invocable method. Notice that as a best practice, provide the label to your invocable Apex method. This helps admins easily find the Apex action. We invoke the Apex class queuePush. This class implements a queuable interface and is allowed to make a third-party callout. Implementing the class with queuable interface makes the actions asynchronous. Asynchronous makes your logic run in a separate transaction. In the execute method, we call invoke web service push method of the web push service class. In invoke web push service, we instantiate an HTTP request system class. We provide the endpoint, we provide the headers, we provide the request body. Notice here we have used named credential. A named credential specifies the URL of a callout endpoint and its required authentication parameters in one definition. Salesforce manages all the authentication for Apex callouts that specify a named credential as the callout endpoint so that your code does not have to. Finally, let's open a flow send web push notification on a new vehicle. This flow is part of the ECars sample app gallery. In this flow, we will see how we can use Apex actions. This is an auto launch flow, meaning it can be called from Apex or REST API. The flow uses a standard flow element which gets all the lead records, and we loop over each record and invoke the send push notification action. If you're looking for more examples of Apex actions and flow screen elements, check out the automation recipes repository on Trailhead Apps GitHub repo. Automation components provide a set of reusable and production-ready extensions. These extensions include invocable actions, flow screen components, and local actions. Let's recap the demo highlights. You can automate your business process on Salesforce with and without code. Salesforce Flow is a low-code tool that your admins or business users can use to add automation. As a developer, you can build Apex invocable flow actions and Lightning Web components that admins can use along with other logical components. You can automate your business process with Procode using Apex triggers. Apex triggers involves writing Apex code. With code, you have the power to perform complex logic. As a developer, make sure to bulkify your trigger Apex code. As a best practice, have a trigger pattern in place to control the order of operations and ease maintenance. Finally, let's look at when to use Salesforce flows versus Apex. Note that Flow record triggered automation and Apex triggers are complementary. Let's first focus on when to choose flows. If admins maintain your code in the future, then Flow is a good choice. If your company do not have access to developers, then Flow is a good choice. Now let's focus on when to choose Apex or a hybrid approach, which uses Apex and flows together. You can choose this approach if you have a well-established continuous integration and continuous delivery for building Salesforce app, and your organization is matured where both admins and developers create and maintain solutions. Finally, you can find all the code that we used in this presentation on our sample app gallery named ECars. You can visit the URL github.com/trailheadapps/ECars to find all the code that we used. Also, we have Trailblazer community groups where you can learn Salesforce with your peers, build your network, and find mentors. If you want to get started with Salesforce development today, check this link in which you will find some useful resources on Trailhead, a fun learning platform. Thank you for watching, and remember to like the video and connect with us in our social channels if you like the session.